So now that you've seen the overview of the structure and functionality of the Handey microservice, let's kind of focus in on how we implement it. And this will give us a chance to show off some cool parallel and sequential Project Reactor implementation variants. And as usual, you can get this from my GitHub repository in the EX4 project, in the Web MVC folder, in the Live Lessons GitHub repo. So we're now in the EX4 project in my Web MVC folder, and let's go ahead and take a look at the Handey implementation, the HandeyApplication microservice. We can find this down here in the Microservices package, and I guess really it's a module. And if you take a look down here, you'll see we've got the microservices, and we're going to take a look at the one that's the Handey one. And we'll also take a look at some of the resources that it uses as well. There's some really cool stuff here. So here is the Handey microservice definition. As you can see, HandeyApplication extends base application and just goes ahead and calls up to that inherited run class that goes ahead and registers things and gets it so it'll work with Eureka, as we'll see. Take a look here at the HandeyController. As we saw before, very simple, just inherits from base controller. No real surprise there. And then over here, we have the HandeyService implementation. But before I show you that, I want to show you where the data comes from here. So you can see that we have this auto-wired list of quotes, and here's where we get that data from. If we go into the Resources folder under Handey, and we take a look at Data SQL, we'll see a little SQL statement. And what it says is it says basically insert into this quote object, which has an ID followed by a quote, all the various quotes from Jack Handey. And again, if you don't know much about Jack Handey, you should Google Jack Handey. He's really funny. He has all these silly quotes. And what we're doing here is we're basically initializing this list with the quotes, which are the second field, and then the default, which is just going to be an incrementing ID that will just keep going up and up and up and up. And over here, you can see that we specify this stuff as follows. This is actually pretty darn cool. You can see that we have the mechanism for defining this particular microservices portion of the code, which says I'm going to rely on Eureka. So we have going to have Eureka being used here as the naming service. We're going to basically be a client of Eureka. And we're going to then define declaratively that the Handey microservice listens to port 9100. The Zippy microservice listens on port 9101. You can see the name of this thing is the Handey microservice. And we define the data set where we can get all the contents for this thing. And you'll see down here, we'll look at this a little bit later, we actually have a way to use a database for the Zippy quotes. And we'll look at that when we get to that point. But without loss of generality, let's pop back over here and take a look at the HandeyService implementation. So we're going to go ahead and get this list of quotes auto-wired in. So those things are going to be auto-wired from that little database we saw. And then down here, we're going to have the various methods. Now, the first method is very simple. It just gets all the quotes. It just returns the list of quotes. That's really very similar to what we've looked at before. The post quotes method and the search method, however, are a little bit more interesting, actually quite a bit more interesting. So they're going to be using the flux and parallel flux mechanisms available with Project Reactor. We'll talk a lot more about that shortly. This is a preview of coming attractions. So the way this works is we take the list of quote IDs, remember that came over in the body of the post request, and we turn that into what's called a flux. And a flux is a reactive type that will emit values. And from iterable is a factory method that connects the non-reactive world, like a list, with the reactive world. We then say, I want this particular flux to run in parallel. And the .parallel operation will convert a flux to a parallel flux. And then we tell that parallel flux, I want you to run on either of these two schedulers. If the parallel parameter is true, I want you to use the parallel scheduler. And if the parallel parameter is false, I want you to use the single-threaded scheduler. So we've got two different schedulers that can be used here, and we can select between them programmatically. And then all the rest of the code is identical. It just runs on one of the other schedulers. If it runs on the parallel scheduler, then this operation here will go ahead and run in parallel. And what that's going to do is it's going to go ahead and get the Handey quote that's associated with the particular quote ID that's coming through from iterables factory method, because the quote IDs are just a list of integers, or initially a list of integers which turns into a flux of integers, which under the right circumstances turns into a parallel flux of integers. And so all these calls are going to run in parallel, very similar to a parallel stream. And then when we're done with getting all the quotes, we go around and say, please convert the parallel flux back into a flux, and then collect all the results into a list, and then go ahead and wait until all the processing is done. So that's the way in which this code works with parallel fluxes. And there's a few subtleties here that are a little tricky, like you have to know how to use the share operation here so it'll work properly with single-threaded resource pools, but that's a minor implementation detail. Let's take a look at the search operation. Search one is kind of even more interesting in a lot of ways. So what search does is it takes a list of queries and a Boolean parameter, and the first thing it does is it goes and it takes that list of queries and it converts it into a regular expression. And here is the regular expression. And if you haven't done this, you should go watch the video I posted this weekend, which shows how I used ChatGPT to generate this regular expression function. So I was having lots of fun with ChatGPT this weekend, and I basically fed it some code that was written in a non-streams way, and I asked it what the code did. And once it realized what the code did, it explained the code, which was correct code. I then said, would you please rewrite the code using Java streams? And it automatically rewrote this exact code. So what happens here is we take the list of queries, we turn it into a stream, so we have a stream of queries. We then use the map operation in order to convert each element in the stream into a so-called quoted pattern, which just deals with any weird characters that happen to be part of the query string that we don't want to be treated as regular expression characters. And then the last thing it does, and this is the part that was so cool with ChatGPT, it uses collect. I knew how to use collect, but it knew how to use the 3-parameter version of collect. And I had known vaguely that such a thing existed, but I'd never really used it, so I only knew the 1-parameter version. But it knew the 3-parameter version. And so what it did is it takes each element in the stream and it inserts a vertical bar between each of them, which is the regular expression syntax for OR. And then it prefixed this particular funky regular expression syntax, which says ignore case and skip over anything up until the word that we're searching for. So that goes at the beginning of the whole regular expression block. And then it appended this at the end. This is saying, and after the word match, if there's a word match, anything else can come as well. So this made the regular expression. It's very concise. It's very cool. And of course, because it's ChatGPT, it also generated the comments. So I was able to get the comments from that. So I thought that was pretty cool because I had written something kind of like this, but my solution wasn't nearly as elegant as ChatGPT's solution. So it was a good example of how you can leverage these large language models to do things for you, including write your comments, which is pretty neat. So we've got this regular expression string, and now we go ahead and have a stream, very much like the one above, for the post quotes method, except this time what we're going to do is we're going to take the list of quotes that we now have here. So we take the list of quotes, convert that into a flux, convert that into a parallel flux, and then we go ahead and decide whether we're going to run on the parallel or sequential scheduler. That's just like before. And now here's where things get different. We're going to use the filter operation, very much like Java Streams filter, and we're going to say for each quote, find anything that matches. And of course, we're going to pass the regular expression query in that we got from our little ChatGPT generated code. And then here's what find any match does. It takes the quote that we pass in here, convert it to lowercase, and then see if it matches anything here, including skipping over new lines. So the .all flag indicates that this funky syntax, $S, tells the regular expression matcher to match across new line characters. This was also something that I figured out by using ChatGPT. My program was not working. I was like, why is my program not working? It should match. And then I went and I looked at the data set, and I realized that for some of these things, there were new lines that were inserted into the input. And by asking ChatGPT a very simple question, why does this code not match? It told me, oh, you need to put this regular expression syntax at the beginning. So boom, that saved me a ton of time. And so this will do the match with the regular expression. And then we take the results of that. If anything matches, it returns true. And then we keep the things that match. We convert the parallel flux back to a sequential flux, collect it into a list, and then block until everything is done. So very cool example. We'll see when we run the test program later how it scales up better because it uses concurrency. And it's also a nice example of how to use ChatGPT as kind of a co-pilot or a mentor to give you feedback. I like to think of ChatGPT as something along the lines of Jarvis from the Iron Man movies, where Tony Stark has this little intelligent being, this AI, what would you call it? I'm not sure it's a being. It's an AI chatbot that he communicates with and brainstorms with. And that's kind of what ChatGPT feels like at this point. Although when it gets things wrong, it gets them monumentally wrong, which is kind of funny. Okay, so that is the end of walking through the